Okay. Whew. God, a bit of a rush there after the keynote. But yeah, welcome to the Firebase face detection presentation. This is something that sort of started off as, for me, like as a side project. So I was just playing around with this stuff. Actually, I started off with text detection, so OCR stuff with Firebase. And then it turned into face detection because it's just a little more sci-fi, a little more cool. So after that, I was asked to turn it into a code lab a few months ago for Google I/O Extended in Denmark. So I turned my code and all the research that I'd done and all the playing around that I'd done into a code lab. So I didn't quite get to have the demo running, which I might do at the end if there's time. But everything that I'm about to show you is available in open source right here. So you can go to that lab and you can go through it and do the lab yourself. If not, you can just download the code and use it to your heart's will. It's all totally free. Yeah, so, sorry, just grab this little thingamajig here. Right, so who the hell am I? My name's Nick. So I come from Australia, but I live in Germany. I've been living in Germany for maybe 5 years or so. I'm a Google developer expert, specializing in Firebase, but actually I'm an Android developer. I'm a very old school freelance Android developer. Getting a bit old in the tooth. I've been around for too long. Yeah, that's my Twitter. You can contact me through Twitter if you like. That's my GitHub. That's interesting for code. And this is basically just a resume that's online. But it also has links to LinkedIn and all that sort of stuff. Enough about me. So what are we going to do today? What am I even talking about? It's a pretty big mouthful, the name of my presentation: real-time, face detection, Firebase, Android. There's lots of words in there. So I made it much easier to understand. It's Snapchat. So what we're basically doing is making something like Snapchat, right? That's the whole point of today. So this is essentially a very bad quality video of the app that you can download, the code that you can run and play with. Now, I broke down my findings. Like, you can sort of think of it like research, but it's more like me just playing around with things. I broke that down into 4 parts to sort of ease you into the idea of face detection in real time. So let's just so I can sort of gauge how fast I should go through things. Has anyone here written an app that actually uses the camera? Yeah? Just 1, 2, 3? Okay. 4? All right, so probably there's like 8. Okay. What did you guys use? Did you use the Android camera? So if you have a look at the documentation for Android and how to use the camera, it's actually quite complicated. I mean, I've been working in Android for a long time, and actually only 2 years ago is the first time that I touched the camera, right? And when I went to the documentation, I expected a nice API, and actually it's really hard. If you use Camera or Camera 2, there's a new one, they're both very, very difficult to get set up. If all you want to do is just take a photo and get it set up, it's quite hard, right? So the first step that I've got here is just setting up our playground, right? Taking a photo and displaying it to the user. That's the first step. Just investigating and understanding how the camera works a little bit. So that's the first step. We're just going to create an app that takes a photo and shows it to the user. Very simple, right? Or at least it sounds simple. The second step is adding Firebase. So adding Firebase is the face detection part. So that's when we're actually going to sort of intercept this little process that we have, taking the photo, giving it to the user. We're going to, in the middle, we're going to give it to Firebase, and it's going to start to detect some faces for us. Third step is my favorite, is getting creative. This is where you can actually start to do some cool stuff with Firebase, right? With the face detection information. So you've gone from just having a bitmap, now you've got some information about the faces inside that bitmap, and the possibilities that come from that are quite amazing, right? And then the very last part is about going real time, so actually doing it in real time, which is probably going to be the shortest part of this speech because it's also the hardest. So, it wouldn't be a lecture unless we had some theory. You need to go through the theory so you actually just understand the words that I use and why, what is actually possible with Firebase. Okay? So let's start with the machine learning kit. There's probably a few other talks here today on machine learning, so I won't spend too much time on this. But the cool things about Firebase machine learning, the Firebase products, are these three. Offline. So offline means two things. First, it means it's free. So if you're doing it with airplane mode or something, it's free, right? So all the machine learning stuff, to a certain extent, it's free. It depends what you want to do with it, of course, but it works on your device free. Okay, that's like amazing. The second thing is it's very easy. So you'll see some of the code later on. It literally, the SDK for doing face detection has just one method, process. So it takes an image, gives you faces. Very simple, input, output. There's no super complicated code or any concepts that are really difficult to understand. So it's quite intuitive, easy to get set up. And the last part is it's extensible. So is anyone like a machine learning genius here? Has anyone got a PhD or something like that? Artificial intelligence, neural networks. I didn't know anything about that, right? I mean, I know a little bit now, but you don't need to. That's the cool thing about this, right? You don't need to know anything about machine learning. You just need to know a little bit about coding. That's it, right? So the thing is, if you do have a PhD and you do want to use your own TensorFlow models or something like that, you can also do that. So it's kind of it can be easy or it can be hard. It's up to you. So, what information can you actually get from a Firebase detection kit, right? Every time you give it a bitmap, it's going to give you a list of faces that it's discovered inside the image. So, what information can we get about each face? This is what you can get here, right? You have a bounding box, and this is the most basic piece of information. Anyone tell me what a bounding box, what they imagine that would be? It's where the face is, that's right. You know, like it's a box around each face. So it gives you the coordinates of the faces, right? Very simple. And you'll always get this. No matter how you set up the detector, you'll always get that bounding box. And that's really important. It's the most simple piece of information, but also the most useful. Then you've got contours and landmarks. These are a little bit more complicated. I'm going to show you exactly what they are in a second. You've got the Euler angles. So the Euler angles are essentially, the 3 dimensions that you can have your face tilting. So you can tilt your face like this, right? That's Euler Y. That's Euler X. So actually, you'll notice that Firebase doesn't have a Euler X because it's not so great at detecting that. And then this one, Euler Z. That's really good. It's really good at detecting that, yeah? Everybody do it together. And then you've got these last ones here. These are classifications. So these are kind of like some things that Firebase people are getting creative and giving you. But they're mostly based on this information. Yeah, mostly the contours. So this information is kind of like an abstraction of this. In my opinion, these are sort of very alpha-ish. They're not very mature. So the results that you get from that are kind of, they need a bit of massaging to become useful, but they're there as kind of like a bit of it's showing you the possibilities of face detection, right? So I'll explain them to you. Obviously, left eye and right open probability is pretty straightforward. It's just like how open your eye is, whether the eyes are open. smiling probability. Anyone can tell me what that is. But these things can be useful. If you've got any sort of old camera, even old cameras had this. It would wait. You can press the button, and the camera will wait until everybody in the picture is smiling, and then it takes the photo. Things like that, right? And the Mona Lisa, yeah. You might be standing there for a while, yeah. And then a tracking ID. This is kind of interesting. The tracking ID is, if I took my camera right now and took a picture of all you guys, it would give each one of you a number, just on my local camera. It doesn't use your private data information, it doesn't use your name or anything, right? Just a number. And then if you all got up and changed seats, it'll find you. You know what I mean? That's the idea behind tracking ID. But again, it's not great. If I was taking a photo of all of you, you'd all be very small faces, so it's not really so great. Maybe if we're all up close, then it's a little bit better, yeah? So, what are contours? This is what a contour looks like. I mean, it's pretty self-explanatory. This is straight out of the documentation. It's a pretty good indication of what a contour actually is. But the useful thing about a contour is this. So, you'll notice here there's little numbers. So all of these contours it's basically just like a big long array of points with segmented into classification. So it's like, okay, you can think of this like a big long array from 1 to 100. The start of the array is the face here, this contour, 35, 36 points. And then the next part is the eye, the next part is this eye. So it's just an array. It's nothing special, no crazy data structure. There's easy ways that will let you pull this information out, but it's really just a big long array. The interesting thing is, so since we're doing a Snapchat app, you might want to use these points as anchor points for a beard, or for, I like to use the analogy of a cigarette, right? So let's say I wanted to put a cigarette in this guy's mouth. He definitely needs to start smoking, right? Take point 2 of his lip here, and point 2 of this lip here. Maybe find the midpoint, and that's where I want my cigarette to go, like that, right? Always. It doesn't matter whose face you use, it's always going to be sitting right there. It's not going to be sitting up here, not going to be sitting up here. Those 2 points, they'll always be the same on every single face. That's the takeaway. There's a lot of other things about contours. The other thing that's really important to understand about contours is that they're expensive, right? Not dollars, but CPU. So it takes a long time to detect CPU contours, and that means that they're expensive. There's more detail, therefore it takes longer. And that's important when it comes to real time. So if you need to detect this very, very quickly, well then you need to start thinking a little bit more about how long it takes to find all these little points. Yeah, landmarks. So landmarks are like the poor man's contours. So they're the same sort of idea, same concept, just not as much detail, right? So you can see here for the eyes, we have 15 points or 16 points. Always off by 1, right? That's such a big problem in programming. 16 points. Over here, we just have 1. But that's good enough, If you just want to put a clown nose on a person's face, all you need is this one. Perfect, right? Much cheaper as well. So detecting landmarks is very, very quick. The process is just like, it'll give you landmarks very quickly. And then classifications, I already went through those. Yeah, so I won't go too much detail. Okay, that's the theory. Not too bad, right? You're still all awake? Excellent. Are you there? Yeah. All right, excellent. It's weird with this microphone. Okay, the first step, scaffolding. All right, all we need to do here is just take a photo, put it on the screen. Pretty straightforward, right? Wrong. It's not. It's really hard, and this takes ages, right? I worked so hard on trying to get camera to work. And I mean, you'll see there's some guys here from Camera X at Google, and Google's trying to solve this problem as well now, right? To just make the camera a little more easy. All I want to do is take a photo. Don't make it so hard. Why? But there are actually some libraries that will help you, and they're kind of more mature. So Camera X is very much in alpha stage, and it's kind of trying to solve a slightly different problem. But there are some, the good news is there are some libraries out there that will help you. Okay, first one, RX permissions. Has anyone used this? RX permissions? Yeah, right on. If you've ever done anything with permissions, I really recommend using this. Even if you're not in RX Java land, that's okay. You don't need to know too much about RX Java. It's just a nicer way of doing permissions. So obviously for using the camera, we need the user's permission to use the camera. So we're going to use RX permissions, and this is all the code you need. Okay, you can just quickly have a look at that. This is all the code you need to ask the user for permission for the camera, right? If you look at the documentation for permissions, you have to do like send intents off to activities and catch on activity results, blah, blah, blah. Painful, right? This is very concise. I mean, I haven't implemented the camera here yet, but yeah. I mean, I'm not going to explain code. It's quite hard to do that. You can just read code. It's easier. I just wanted to sort of show you what's possible. Again, all these slides will be up on Twitter and whatever, so don't feel like you need to like really understand this perfectly. It's just to show you how quick and easy it is to get permissions working. Yeah. Next, set up the camera. All right. Now, after I got sick of trying to figure out camera, a friend of mine put me onto this library. This is essentially like a more mature version of Camera X. So Camera X is, like I said, it's trying to solve a slightly more different problem, more modern way. But this is a much more mature library. Again, it's free, that allows you just to take a photo. I just want to take a photo. I don't want to like write a crazy amount of stuff. I just want to take a photo. I just want to start, right? So photo apparat, recommend it. This is all you need to do to get a photo to happen with photo apparat. And has anyone played with Camera X yet? Yeah, a couple of you guys. So you'll notice some similarities, right? I don't know if Camera X guys have been using this as well. I don't know. Maybe they have. Let's see. So first of all, you need the implementation, of course. We're adding another library, another dependency. A camera view. And this is essentially just a wrapper around a surface view for showing our preview on the screen. Again, similar to Camera X. We're creating our camera. And this is, again, just an object with a whole bunch of configuration options. I mean, this is just a few. This goes on and on and on and on. There's a million ways you can set up the camera, but this is just very minimal, right? I'm just telling it, obviously, context. Everything in Android needs context. The view, so this is pointing to this view here. How we're going to scale it, you would have seen that from if you've ever used an image view. And the lens position. Are we going to talk to the lens, the front camera, or the back camera? That's it. I mean, there's lots of, like I said, lots of configuration options there. Not going to go into them. I'm going to show you the most simple, basic case. Now, take picture. To bitmap, when available, we have a bitmap. Man, I mean, that's 4 lines of code. Have a look at the documentation for camera in the Android documentation, right? This just blew my mind. When I got that, I'm like, okay, I'm back on this project. I'll start doing it more again now, right? So again, photo apparat, remember it. Now, second part, interesting part, detecting faces. Okay, so now we have an app that will just take a photo, put it on the screen. Now we want to put some boxes around that face. Simple, right? We just want to put a box. Okay, and then we've got our bounding box, right? That's obviously probably jumping into your head. But we need to set up Firebase first. Now, Firebase is people here using Firebase? How many people are using Firebase or have used it before? Yeah, cool. All right, now apart from the whole Google services problem, really easy to set up, right? I mean, I know that you guys have I don't know if it's here, but in Myanmar it was like that. Lots of Google phone, Chinese phones, and Google Play services is a bit of a problem. I don't have it on good authority, but I think that Firebase is trying to remove Google services from Firebase libraries that don't really need it. Yeah, some of them do, some of them don't. But I mean, so remote config, for example, they took Google Play services out of that, just so that it's more accessible. Yeah. So okay, blah blah blah. Setting up Firebase. I'm not going to go into too much detail here because it's just documentation. You can find this online, and it's very very straightforward. But the interesting stuff is, obviously another implementation. You need to add another implementation, another dependency if you want to use contours and IDs. It's kind of important because it will download a TensorFlow model onto the device in the background on the user's first usage, right? So that's just sort of a little gotcha. You can't use this completely offline. The user has to go online just at the start, just to download this model, and then you can go offline. Yeah. So let's talk about how we're going to do this. So, okay, it sounds simple. We've got a bitmap. We're going to give it to Firebase. It's going to give us some faces, and then we're going to draw a bitmap. Right? Sounds pretty easy. And when I started to do this, I just went and just put it all into my activity. You know, architecture. Who cares? Whatever. Just get it working. Blah blah blah. Then I changed my mind, and actually I found. Actually, I stole this from the Firebase sort of example kit. So once you start doing this in real time and you start wanting to add more like hats and glasses and all different types of graphics, well then your activity starts to get crazy. And there's this concept. So we start to like separate our concerns, right? Try to be solid as possible. So came up with these two ideas. I actually changed the names of them a little bit. So I call it a plugin and a graphic. Now, a plugin is kind of like a filter in Snapchat, I think. So in Snapchat, you have the bunny filter, you know, and then it gives you little ears and floppy ears and little like cute nose and whatever. Maybe you have the hipster one who has a beard and some glasses and a hat or whatever. A rock star one. These are all the plugins. They're examples of plugins, yeah? And then a graphic is inside a plugin, so they belong to a plugin. So you might have the beard graphic, you might have the glasses graphic, the bunny ears graphic, and they can be reused, right? But the idea is we're separating the drawing of the graphics from the detection of the faces, yeah? So let's talk about a plugin. We're going to make an interface for a plugin, and it's very simple. Process, bitmap, and give me a bitmap back. Yeah, so remember I was talking about take a photo, display a photo, yeah, going all the way back to here. Bitmap in, bitmap out. That's the idea behind a plugin. We just give it a bitmap, and it's going to give us a bitmap back at some point. But a plugin is doing more than that, right? So its job is to detect faces, that's all. So we have to think about what we need, what information we need from that. So if we're going to do a clown plugin, then we're going to need information about where the nose is, right? And we talked about landmarks, so we're going to need landmarks. But we don't need classifications, we don't need contours. So that's kind of that's the job, that's the implementation of a clown plugin, yeah? But we're just going to do a box plugin. So, yeah. So sorry, I'll back up a bit. So here's the detection options, right? So here's how we build a detector in Firebase. We have basically 5 options that we can turn on and off. Well, they're all on and off except for this part here. I'll do that in a second. But here's your options, right? So performance mode, do you want it to be fast or accurate? Classification mode, all classifications or no classifications. So this is basically on or off, right? There's no other like in-between options. Landmarks, contours, classifications. Performance mode is a little bit magic. I don't actually know what that does exactly, to be honest. But yeah, I think it kind of just tells Firebase what you're doing a little bit, right? Whether it should be going into a lot of detail or whether you're using this in real time, so it will kind of cut out some processing at some point. The min face size is interesting. This has actually just been added in the last month or so, and this will block out background faces. So you can say that the minimum face size is, here I'm saying 10%. So if the picture is 1000 by 1000 pixels, well then the smallest face, the smallest face has to be 100 by 100, yeah. 10% of the size of the picture. That means that you're going to have to be pretty close before Firebase will even start detecting anything, yeah? Which is very useful because the more faces that are in a picture, the longer it takes, yeah, to process. More CPU time, yeah. But yeah, so in our plugin, we really have to think hard about what options we're going to use. That's the idea. That's the plugin's job. Graphic. Okay, so the plugin is going to detect faces, right? And then it's going to tell our graphics, okay, here's the original bitmap that we have. Here's all the faces that we've detected. Draw, right? So a graphic is going to take care of the drawing. It's got the information about the faces, it's going to do some drawing, and then it's going to send back a bitmap. So it's kind of like the workhorse. It's, you know, a graphic would be like a beard graphic, or a nose graphic, or sunglasses graphic. Make sense? Yeah, essentially just a separation of concerns. Not really getting it? Let's do an example, right? Our first plugin is going to be the box plugin. Yeah, this is what we're going to do. A very simple exercise. I know it's sometimes it's annoying when people do really like simple hello world stuff, but yeah, I just don't have so much time. But hopefully you get the idea. So let's start with our graphic. So the graphic that we're going to draw is a box, just a simple white box around every single face. That's all we need to do. So yeah, we inherit from implementing the graphic interface. We're taking a bitmap. We've got a bunch of faces, and we've got a bitmap back. Right now, we're just returning the exact same bitmap. We're not doing anything. So let's start doing something. First thing we need to do is create some paint. Has anyone done any custom views? And people, have you guys used paint before? Yeah, doing like custom graphs and stuff like that, for sure. So this might be a little bit more familiar to you. Actually, what we're doing here is almost like a custom view. So now we've got some paint. We're going to wrap our bitmap in a canvas, and this is going to let us draw on top of the bitmap. And it's funny, I never really understood so deeply what a canvas was until I started doing this, right? Because the interesting thing, and it was brought up in my last talk, is that you can draw on top of this bitmap, but you can't really alter it, okay? And that's kind of important later on. So anyway, we're going to wrap our bitmap in a canvas, and then for each face, we're going to draw a rectangle around the face's bounding box. So we've got some information about the face, and we're using white paint just to draw a rectangle. Done. That's it. Yeah? Not much code, hey? Like, nice and simple. So let's talk about the next part, the plugin. So we've done our graphic. We've got a graphic that's going to draw a box around every single face. But now we have to actually give it the faces to get it to work, right? So again, we're implementing this plugin interface, which you can see here. Here I've added the camera direction, which is, actually I should have taken it out. So now I have to explain it. Okay, the interface that I showed you actually just had these two in there, but I've added this camera direction, and that's actually an implementation thing. So if you're using the front camera, it's fine. If you're using the back camera, then you need to flip all your points. They all need to be flipped, otherwise the boxes will be not on the faces, right? Whatever. let's talk about how we're going to detect. So this is kind of the, if you don't listen to anything else I've said here, this is the important part, right? So wake up. All right, gotcha. All right, so you've seen this part before, okay? Options. I'm just telling it that I want it to be fast. I don't care about contours, landmarks, none of that stuff, right? All I care is that it's fast because I know that I'm going to get the bounding box. That's all I need. The detector is, this is all the information, this is all the code you need to do some very, very simple face detection. That's it. It's not much at all, right? To actually get a detector and use the actual SDK. So here's the entry point into the Firebase SDK. All right. You'll notice that we have to wrap it in a bitmap, in a Firebase vision image, but they have a whole bunch of very simple, like sort of factory classes for creating the Firebase vision image. And then, dun, 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 detect an image. That is the entry point into the Firebase SDK. That's kind of like the hot line of code, right? That's where you do detection. Boom, right? Detect in image, give me faces, done. Nothing crazy, complicated, no like C++. It's just like bitmap in, faces out. That's cool, right? That's sci-fi stuff. 10 years ago, that would CIA stuff, right? FBI, airports. Now you're doing it on your phone. Yeah, awesome. Okay, how does this interact? So now we create our box face graphic and we just draw the bitmap and the faces. It gives us back a bitmap with faces and we give that back to whoever's calling here. So this is our activity, right? Our activity is calling simple box plugin dot process. Here's the bitmap we got from the camera, and it's going to be sitting there waiting for a bitmap from us. Here we give it to it. Make sense?
Yeah.
Cool. All right. All right. That's the end of part 2. Part 3 is the fun part. Now, is anyone keeping time? Does anyone have an idea about halfway? 30 minutes or so. Okay, at this point, you have all the information, right? I've just given you a whole bunch of information on what you can do with face detection, all the types of things that you can read from a face, what kind of information you can get, how much detail. Does anyone have an idea? It's an open question, right? It's not a right or wrong question. Has anyone in their head right now got an idea of something that they could do with face detection, besides the Snapchat app, right? Anyone? Got an idea? No?
Deep fake.
Sorry?
Deep fake.
Deep?
Fake.
Deep fake? You want to fake a face or something?
Yeah.
Okay.
Something like this.
Yeah, maybe. I don't know what that is, really, but
You should search it up.
deep fake. I'm not sure. Yeah, okay. Maybe I'm too old for that, man. Yeah. Oh, replacing the face
It's
with.
like taking someone's face and putting it on someone else's body.
Ah, right. Yeah. I've seen an app that does this.
Neural networks, it looks like real.
Yeah. Okay, that's cool. Yeah, I've seen that before, right? Where you take a photo and it basically will switch your faces. That's that's awesome. That's awesome, mate. You can do that. And actually, maybe I'll do that in my next plugin. Because that's fun, yeah, for sure. And you can do that really easily, yeah. Awesome. Cool. All right. Like at least I got one. That's the first person that's actually said yes. Here's an idea. Like, cool. But I mean, I don't know. Like when I got to this stage, I was thinking about things. And what I ended up doing is things that you've already kind of seen, and they're kind of stupid, but it's about exploring those possibilities, right? So here's some of the ones that I did. Again, like I said, pretty stupid, like deepfake. I mean, I mean, this is basically the bounding box thing, except drawing a face instead of a bitmap. And this is using the contours and just drawing lines in between the contours. Again, pretty boring. This one's interesting. This is my original idea, was to film criminals, right? And just like redact their faces. But this one's interesting because it's actually, these ones are using the canvas, right? So you're just drawing on top of the bitmap. This one, you actually have to extract some information from the bitmap or alter the bitmap itself. And that's a little more complicated. For this one, it's such a subtle difference, but this one I had to use something called render script. Have you guys used that or seen it? It's brutal, it's brutal. Oh man. I mean, it's like C++ essentially, right? But yeah, I won't go into that, but that was also, it's also in the code online if you're interested. So, what you all came here for? Keeping it real. Like, I've almost done the entire presentation on image, right? Just taking a photo and processing the photo, right? Like, boring. There's nothing real-time about that, right? You came here to see some real-time stuff. The reason that I do that is because it's really important that you understand your idea first. You know, that's why I'm asking about ideas. If you have an idea, you really need to solidify it and understand what you're going to be doing to every single bitmap that's coming in. And you want to make that as tight as possible, yeah? And you don't want to have to worry about that when you're coming over to real-time land, because real-time land is messy, it's ugly, it's brutal, and it's hard, yeah? You want to be thinking about performance over here. That's the hard part, right? Because it's really, really important that things work very smoothly. So it's all about performance. So I'm not going to be talking about face detection, not much at all, anyway. We're going to be talking about performance. So remember I was talking about doing this with text recognition to start with. This is kind of like my first attempt at this. And you can see it's janky, it's really not real time, yeah? It's like, this is actually using photo apparat still. Photo apparat, just like Camera X, has a way of hooking in to the camera and getting the preview frames before they hit the screen. Oh, sorry, while they're hitting the screen. So the preview frames are hitting the screen, and you're doing some analysis and then drawing these boxes on top of the preview frame. So this is actually, you can see, how's it point up? Okay. Yeah, this part here is the camera, and it's pointing at a piece of paper. Yeah, so this is the actual preview surface view, and then I have another view over the top of it, and the other view is drawing some boxes. So there's actually overlapping views in the XML hierarchy. Naughty! Don't do that, right? It doesn't work properly, and I got in trouble for doing that, and I paid for it, right? When I looked at this and I got that working, I'm like, what the hell, it's not working properly, this sucks. And you start looking for ways to optimize how the boxes are drawing, and you slow down stuff. Wrong, scrap it. The very first line, I went to Firebase about this, and they said, read the manual, dude, right? So you go online, and it says performance tips. There's like a whole section on performance tips in Firebase. The first one is, don't render twice on the UI, right? Don't do this, right? This is what I was doing. So here's the camera. We're getting frames. So this is the frame going straight onto that surface view, right? And then we have this little hook that you can hook in, and it's going into our plugin. It's creating some graphics, and it's being put on the view. And the combination of these two is happening in the view. Very bad. Don't do that. Do this. Take it straight from the camera into the plugin, combine the frame and the graphics, and then put it on the view, right? In a serial line. So the view, all it's doing is just getting a bunch of bitmaps, right? That's the biggest performance tip I can give you. There's lots and lots of people out there online, which I found, who are doing it this way, right? and just really trying hard to perfect that way. Trust me, once you go from that to this, it's just like 5x, 10x, 100x, whatever. It's a massive performance improvement, right? Huge, absolutely huge. Even though we're using bitmaps, so another thing is like bitmaps are not so great. If you can escape from that, cool. I haven't figured out a way to do that yet, but bitmaps are not so great. Anyone, whoever's ever done any processing with bitmaps, you'll know that creating bitmaps are kind of expensive. And even if you're doing the bitmap manipulation on the UI thread, it's totally fine. The rendering is keep it away from the rendering engine. Yeah. So UI thread, don't render twice. If you get everything that I say here today, remember that. Okay, other ways that you can do things. Drop frames. So actually, drop frames you have to do. So throttling is very important. The camera is going to give you a whole bunch of frames very quickly, like this. It's just like, here's one, here they go. But Firebase is a bit slow, right? You need to, okay, it's giving them to you at 20 per second or something like that, right? So that means 50 milliseconds. You've got 50 milliseconds to process and render your bitmap so that you can get to the next one and do the same, yeah? But what if your processing takes 70 milliseconds, right? Now you've got a lag, all right? And it's really important to handle this lag because you'll have a queue of things, and if you don't manage it, your thread count will go up, your memory will expand, and it'll just crash. So what do? We drop them. So we're going to ask for a frame, and then we say, 5 minutes? All right, not much time. We're going to ask for them, and then we're going to drop them. You know, if we're taking too long, we just say, no, forget that one, go to the next one. And what happens is you get a sort of a janking feeling, right? And actually, I haven't perfected this, so I'm going to show you a demo. Maybe that's going to be more interesting than all this stuff. But there's just a couple of other little tiny things. You can lower the preview resolution. So when you're asking the camera for frames, you want to make it small because processing a 4K frame it takes a lot of time, and that's bad, right? More time, bad in real-time land. Yeah, this is not so interesting. Using threads or coroutines, maybe. The big one though is detector parameters. I've already gone through this, but essentially you want to use the least amount of parameters as possible. Right? I've showed you how to use all of them. You want to use the minimum. Okay, that's basically it. Just before I go, I'm going to try and get this working, and I'll just show you what it looks like very quickly. Okay. Exit. Fuck. Man. Yeah, maybe that. We can try that. Kill what? Oh, kill minus. Come on, buddy. Bah! Okay, it's not really going to work. It's not being nice to me. Maybe I don't have this working on my phone, USB debugging or whatever. I'll just show you without it. Okay. Okay, wait. Okay, see if it works. All right, so I'll just like show it to you like that so you can see yourselves in there. Yeah, that's essentially what it happens. It's not recording or anything, don't worry. Yeah, it's just showing you like how fast it is and what's kind of possible at least, you know, yeah. Actually, it's better when it's up close anyway, you know. That's you guys. And then there's other ones, so, oh wait, already did that one. So then the blurring as well, it's very similar. You can blur people's faces out. Yeah. So this code, this app, this exact app, it's all online with all the code open source. Up to you guys to just like grab it and have a little look, and contribute if you would like. Yeah. Well. All right, cool. That's it for me. Thank you very much.